Testing, testing. Cool. All right, so let's dive into it. So on-chain AI agents is definitely a new space. It's got a lot of innovation happening underneath the hood. And we have two founders here who are both working on this problem directly. To kick it off, maybe we could tell us a little bit about the projects you guys are working on and maybe introduce yourselves.
Hey, I'm David. I'm co-founder of Valerie. And Valerie itself and a whole bunch of other people co-founded and co-created Autonolas. Now we mostly refer to it as Olas. My background is in economics originally, and then I went into sort of this intersection of machine learning, economics, and crypto, at which agents sit. And I'm excited to be here.
Awesome.
Yeah, so hi, I'm Richard. I'm the co-founder of NapthaAI. I was previously the co-founder of Algovera. I've been working in the AI crypto space for almost 3 years now. My background is in machine learning. I worked in big tech companies as a machine learning engineer, mostly in generative AI and putting generative AI into products like pipelines, workflows, that sort of thing. I fell down the crypto rabbit hole maybe like 3.5, 4 years ago, and then decided to find where I could contribute on the AI side of things. Realized there was basically nothing going on at the intersection of AI crypto, but thought it was an interesting intersection, so decided to keep exploring it. And it's great to see it picking up so much excitement these days.
Awesome. And I guess to kick us off then, so how do you define an AI agent? Like, I've seen this term floated around a lot. We've floated around a lot here today. How would you guys describe an AI agent?
I know David has strong opinions on this, so why don't you go ahead?
All right. Let's see. I think the key thing is that there's probably no single right definition. Just important to, I think, differentiate a couple of different types to make it clear when we're talking about one of them. So I think the key distinguishing factors between like fully autonomous agents with AI capabilities and more sort of, well, not really autonomous systems, maybe, short-lived agent-like software tools which help you get stuff done in the context of like some product.
Yeah, I think I've seen a few different definitions. I think we'll probably start to define these better. But like an agent could be, I mean, people use this broadly, so what people call an agent in the AI space can be quite different. A lot of the time when people say agent, what they really mean is some sort of workflow, like a line chain or workflow or something like that. People often call those agents, but really it's just a sequence of steps to do something. Then in certain steps in the pipeline, you can kind of introduce this autonomy aspect, which basically gives some sort of decision-making over to the agent to decide whether they finish that step or not. So yeah, I would say I would also distinguish agents from autonomous agents. I think agents are more like workflows and that sort of thing, whereas like an autonomous agent is one that has a bit more independence to decide how many steps to take in solving a task or something like that.
Awesome. And what kind of infrastructure would you say is needed for something like an autonomous agent?
Yeah, I think we need a lot of infrastructure actually. So like there's lots of great projects building, different layers in the stack and that sort of thing. I actually think we need to put a lot of these different layers together to support autonomous agents. So for example, Olas have built a bunch of different layers in the stack. The Olas protocol, for example, is kind of like more the ownership layer, the access control, the kind of marketplace, that sort of thing. But I also know that Valerie want to build this like agent framework, open autonomy. What we focus on at Naptha is more closer to the compute and the kind of like operations or orchestrations. So yeah, basically I think we need to put all of these different layers together to support agents. And that includes, for example, the compute layer, the orchestration or the LM ops layer, the agent framework layer, the marketplace, the ownership, access control. There's a lot of different stuff we need to put together to support autonomous agents, I think.
Yeah, and do you hear me? Yeah, I think one of the exciting things about building autonomous agents and agents more generally is that, like us humans, I mean, humans are agents as well. Maybe just quick step back to the definition. We didn't actually properly define it. Like an agent is something which, perceives something, does some internal compute, and then acts. So that's the most sort of abstract definition. And so like humans, agents need various technologies to get stuff done. So if we thinking about the crypto context, right, they need like an RPC to start with to talk to the chain. They need probably an indexer because they're not gonna wanna build up that on the fly. They need various off-chain databases or on-chain systems like RV or other permanent solutions. They then have various compute requirements, right? Like where they actually run, but maybe they're also outsourcing various tasks to other agents when we get to multi-agent systems. And then also, because we're talking about on-chain, off-chain, there's this, like, the agent as this kind of abstract thing, right? Could actually live like entirely off-chain as a piece of software there where it runs on a decentralized or centralized substrate. And it could also partially live on-chain in the sense that either, like in Olas, it's anchored on-chain, has like its wallets there, has its like staking mechanism there and so on. Or it could be maybe like almost like a smart contract where you use some form of zkML or something to bring a lot of the actual capabilities on-chain. And obviously all these kind of flavors of design have their relevance for different use cases. I think personally, I always think it's important to consider the whole agent only autonomous if it actually has autonomy. So I would, for instance, personally not consider a smart contract in itself an autonomous agent because someone has to call it, and then you have this whole question as to what's calling it and why. So yeah, but coming back to your question, we have a lot of different technologies there. Then on agents are being built outside of crypto. So there's this whole sets of frameworks which are like totally focused on large language models as sort of wrappers around them, basically fancy loops which use large language models as a thinking tool, so to speak. And they might then, use like centralized equivalents of these various technologies. What I think, to close off on this, is very exciting about agents and building in agents is that you, particularly when you're building autonomous agents, you're effectively building a user. And so that user might have its own owner, right? Someone who derives value from it. But so from a value proposition towards all the protocols you're integrating with, all the technologies you're integrating with, you create a lot of synergies because effectively everyone wins if there's more of these synthetic users. And that is something certainly at Olas, and like with Richard here, we actually work closely together as well. I see every day where like building an autonomous agent has this really positive feedback loop when you think of them as daily active users of protocols and chains, basically.
Awesome. And yeah, we mentioned here, so you mentioned like LangChain, you mentioned other frameworks like AutoGPT or Baby AGI, some of these. I'm curious from a use case perspective, so maybe starting with the more traditional agents, like what are some of the common use cases there, and then maybe we'll dive into the autonomous agents from there.
Yeah, sure. I think like the big first use case that LLMs got were in these like chat assistants, right? So you can do retrieval augmented generation over a database or something like that. And yeah, basically build these personalized chat assistants that are experts on a certain topic or something like that. I actually don't think that's a great use case for decentralized AI, just because it needs real-time performance, right? So if you're talking to a chatbot, you need to have really fast response times. And I don't think that's something that, at least at the start, decentralized AI infrastructure is going to support. The ones that I think are most interesting now are agents that are doing some sort of like data processing or workflow in the background. So what we're particularly focused on are any sort of automations that you might use something like Zapier for, right? Like, I don't know, maybe like read a Slack channel in the background, generate some sort of summary. That's something that doesn't need real-time performance, and so could run on top of decentralized compute, or interact with smart contracts, which can be slow, right? So I think, yeah, that one of the things we're working on with Olas, for example, are prediction agents, which don't need to be real-time performance, right? You can have something like a researcher agent. I guess the goal here, right, is to answer a question about a prediction. Will an event happen before a certain date or something like that? What we built were these research agents that they go out, they do some Google search, they try and find some information on the topic. They do some sort of reasoning, and then they make a prediction in this prediction market. And that's a really good example of something that can run on top of decentralized infrastructure.
Yeah, great points. And adding to the prior category, I think there's also things like wallet integrations around security, for instance. Like, obviously, probably all of us know Tenderly, like these simulations, but you can then imagine there's like some sort of AI layer on top of that as well. And then there's, as we're moving towards more the autonomous agents, I think there's this whole gaming space where there's clearly like a big role for autonomous agents. I mean, they can be non-player characters, or they can actually be player characters as well. And you can have things like, I'm sure there's like lots of protocols here as well. I've seen from other events as well, where it's almost like your companions maybe who act on your behalf or just there for you, effectively, more like a social product. And I think where the prediction use case is a particularly exciting one, because I mean, it's kind of proven that, well, at least within certain limits, that prediction markets, haven't really taken off. And I mean, it's not so surprising, personally. I mean, I'm not, I might care about the prediction markets output, so to speak. Like, I might care very much about the economic relevance behind some prediction. But as a user, I have yet to come across someone who is actually sitting there every day and doing that, and interacting with these markets. And autonomous AI agents are like fantastic for that, right? I mean, you basically have, we've already shown this. I mean, it's actually quite easy to beat a human at some point, even with like simple questions like, has this event actually happened? Autonomous AI agent, can just do this in the background. You as a human are probably gonna get quite lazy after you've seen the fifth link on Google, and then give up. So there are those use cases, and then I think so far all of them are sort of basically single agents or single autonomous agents doing things or complementing your experience. And then we go to multi-agent interactions. And the prediction market is an example there, because in order to get fully AI-based prediction markets, you've got to have a bunch of different types of agents, those who provide the liquidity and open the markets, and those who close them, those who trade in them. And then, as Richard was pointing out, you're probably going to outsource like things like researching and so on. And so now what you start having is effectively like specialization, like we have it in the real economy. And I think I'll pause here because we're going to talk about economies. But yeah, so the multi-agent system is like a huge area with a lot of use cases, in my opinion.
Can I just add one more? Because you mentioned it in your talk, Justin, the Stanford and Google generative AI, generative agents paper. That's the sort of thing that would be really cool to run on top of decentralized compute, right? At the moment, that simulation had happened between 25 different agents. They were all given backstories and they interacted in this world. But all of those agents, that whole simulation was just run on one node, right? And so you're kind of limited in the amount of agents that you can simulate. And they only simulated it for like 2 days worth of virtual world time, right? What if we wanted to run a simulation of millions of different agents with different backstories, right? Or for longer than 2 days? I don't think you're going to be able to do that on top of centralized infrastructure. And that's one of the things that we want to show as a proof of concept with NapthaAI is something like the Stanford Google Generative Agents paper, except where each agent runs on a different node and takes part in this multi-agent orchestration. And I think once we start doing stuff like that, we're going to open up totally new use cases that can only run on top of decentralized AI infrastructure, right? They're the ones that are really interesting.
Yeah, that's really cool. So yeah, like multi-agents and gaming, prediction markets. You also mentioned like the wallet side, which I've seen this. I believe you guys did an experiment with this. Dane on Solana also kind of did like having an agent as a signer for a multi-sig, for example. Or are there like other examples there on the wallet side that you guys can think of?
Yeah, so actually, short plug on Autonolas. We like fully have embraced account abstraction basically, and every agent is effectively like this on-chain multi-sig as well as this off-chain compute system, and then like it can have, as I said before, different legs and arms which kind of complement it. Now, what's exciting about this is like, firstly, it separates your assets from your signing key, which is sort of the same thing as for users again. I mean, a lot of this autonomous AI agent stuff is actually you just have to think about your own life, and then you kind of see it doesn't make sense if software does that, right? Can I build it? But yeah, so you separate these two things, and so you get the benefits of, like, for instance, with the safe multisig, that then you can have all these plugins which further constrain, or modules or whatever they're called, but like basically these things which constrain further on-chain what the signers off-chain can actually enact on this. So then you can imagine a situation where either the human who owns this agent or another agent who owns that agent can further constrain that system. And I think Dane, I mean, I've never actually seen the code, but I imagine they do something like similar.
Yeah, we actually haven't worked personally on the wallet stuff, but there's definitely some really cool projects that are. I know Brian Knows AI is like an AI assistant that's really good at interacting with crypto tools. That's one of the things that agents do. They just they can interact with tools, right? So anything that's an API, an agent can potentially interact with. And so hopefully what we'll have at some point in future is like a library of all of these different tools that agents can interact with, and a wallet is one of those, right? So Brian Knows AI make this much easier. I think like Polywrap have an assistant that interacts with wallets and that sort of thing. And everyone knows that crypto UX can be lacking a little bit. So if we have our own agents that can kind of like do the, a lot of the signing that is a bit tedious for humans, I think that's a really promising direction, although there's like big security questions that we have to answer as well. Do I want my agent signing this transaction?
On that note, I am curious. So, like, obviously we can run the models on like decentralized compute, like you mentioned. But what about for like verification of inference? Is that important? Are there like optimistic models you're looking at, or is like ZKML, which still has a little bit to go before we're verifying agents in a ZK circuit? But curious if you guys have any perspective there.
Yeah, I think these all have their place, right? Like ZK definitely has use cases where that would be really important. There's lots of places where you would want to verify the compute. We kind of try to do more than just stuff that you would want to do verification for. I think like the stuff that ZK and Optimistic is useful for is like a subset of all of the different use cases, right? So we're trying to solve for the kind of broader category first, but then also support people if they want to do verification or ZK or whatever. How I kind of think this is going to look is, again, we need to like aggregate all of these different tools and layers that we're building. So at the moment, we have a lot of different compute networks. We have a lot of different projects focusing on ZK. What we actually need is some sort of like aggregator platform that gives you access to kind of general purpose compute or optimistic compute or ZK, kind of like AWS gives you access to a lot of different products, whether it's EC2 or whatever else, right? I think that's kind of the next stage in this building this new type of platform, decentralized AI platform that we haven't seen yet. So hopefully have something like AWS where if you want to do ZK, you can do ZK. If you want to do optimistic, you can do optimistic. And it'll all just kind of tie together seamlessly. But we're not there yet, I guess.
Yeah, and then it also always depends on the use case, obviously. So for instance, if you go back to the prediction markets, the actual thing you care about are these markets and effectively like the economic might which is behind any given prediction, right? And so it doesn't really matter whether any given agent is, let's say, verified, right? I mean, you as a human aren't verified either, so to speak. But then you have other use cases. So for instance, we had this, and still have this governance use case where it's called Governator. And what it does is you can delegate it's your tokens, and it will act like a human delegate. It will just vote in proposals. Which is obviously useful because you tend to not vote in things, and so you can kind of delegate this to an autonomous system. Now the concern is that if you do that, well, how well will this system actually like enact what you intended to do, right? And the thing here is this quite interesting to pick this apart. So it's currently running as a sort of optimistic system, but with a twist. So in OLAS, one of the benefits is that with the same stack, you can run the same agent as a centralized single node off-chain system, or you can run it as a multi-node off-chain system, which has similar properties like your sovereign blockchain, right? Now, any of those autonomous services, as we call them, is configurable to be 1 to n nodes, and so you can kind of define the properties. And now, in the system, particularly, we use large language models. And with large language models, the next complexity here is that they're not necessarily even deterministic. So then your whole, verifiability approach doesn't really take you anywhere. So what it's all about is effectively aggregating different kind of queries to different LLMs, right? And so that's what the system is doing. So it's almost like there's a group of, you could imagine like humans, but now they're software agents off-chain, all thinking about that proposal with those instructions which were given to it, and then they come to consensus on what they should be doing. And then, yes, we have seen like Modulus Labs, EasyCal, Giza, lots of great projects doing very fantastic stuff on like actually, there you go, verifying various compute. But yeah, as I will tell you as well, like that obviously is still quite limited. And again, I think even in the distant future where it will be accessible, it will not always make sense, right? So again, coming back to the prediction agent use case, you don't care whether the individual agents actually implement some code they should be implementing, quote unquote. What you care about is that there's a lot of individual participants putting their own money behind their predictions. And so, the underlying compute is irrelevant.
That makes sense. So I guess like stepping back for a second, like Web3 versus Web2 for agent rails. Like I mentioned this in my presentation, like I don't imagine that the fiat system can like appropriately account for these types of agents interacting in economics. But I'm curious, like outside of just maybe the payment rails, like how does this experience kind of what's like the differentiating factors between like the Web3 agent versus like a Web2 agent, if that makes sense?
Yeah, I think like private data is a big one as well. Like the Web2 approach to having an agent for someone would be running it on some hosted service, right? And I think agents are gonna, if you're gonna have a personal assistant that is an agent, they're gonna be dealing with a lot of data about your calendar and various different, maybe health stuff, who knows. I don't think we want to have this all on someone else's cloud, right? And so I think some of the biggest use cases for agents are going to be, running locally on laptops, using private data that is like secure. So I think that's going to be a big difference with the Web 2 space as well. That's going to open up a bunch of use cases that aren't going to be possible with Web 2.
Real quick on that, so like local agents being run, what's kind of like the hardware requirement for like the average user to do something like that?
Yeah, like LLMs run on laptops now and phones. So if you have there's a bunch of 3 billion parameter models. Actually, Google just released one, right? Gemma. I think it's around 3 billion parameters. It's made to run on phones, and so they've open sourced it as well. There's, you can run a 7 billion parameter model on a MacBook with some of the good chips. So these LLMs are already running locally on laptops. There's a really good software package called Olama, which is kind of like Docker for LLMs, and you can just kind of pull it and run it locally. It works surprisingly fast. It can be even faster than like something that's hosted on the cloud further away from you. So we're kind of already there with running LLMs locally. We're just missing some of the like frameworks around that. But there's a bunch of agent projects like, say, Super AGI. They allow you to run download software and run an agent with a local LLM plus like a vector DB plus like some other components locally. I think what we focus on at NapthaAI is not just like running these agent frameworks locally on a laptop, but how do we get all of these different agent frameworks talking? So what if everyone here had Super AGI on their laptop? How could we get some sort of orchestration across all of those agents? That's the bit that I think Web3 can help with, is like the networking of those different agents.
Did you have anything to add on the Web3 versus Web 2? Or?
Yeah, for sure. Yeah, let's go back to the banking. I mean, everything that was said was right. I mean, it sort of the key thing here is KYC, right? So basically that is banking, but also any other centralized service. And if we take the antithesis, like maybe we don't need crypto native agents, then the way you would go about this, and there's projects trying this, is you either have some sort of whitelisted APIs for agents, or you build agents which basically fake to be the user. So they're kind of maybe embedded in your browser, and then they kind of actually use your browser like you would as a user, and like log into your banking account and then do something and so on. I mean, frankly, I don't think that's going to be the way, but let's try. With the crypto native approach, obviously, it's like it extends across any kind of API, right? That's the whole reason why we're all here. It's like you have a wallet, you sign messages, and you get access, and who is behind that wallet can be 100 times the same person, can be 100 different people, who knows? So there's this big unlock from just doing that crypto natively. So for instance, going back to the prediction agent use case, the agents don't run the agents which take positions in the market don't run their large language models locally, because that and don't even do their research locally, because that would basically mean that as an operator who has to run this, the whole requirements are much bigger. Instead, there's multiple agents interacting, right? And so we come to your composability point. Again, I think there's where from a theoretic point of view, a philosophical point of view, Web3 has a leg up. Now, obviously, Web 2 cracks the UX always better so far. And so we really need to nail that. I think I'm very confident that basically, like, we will very much see most agents ultimately being Web3 native, because the alternative is you have like some centralized hub via which everything runs, and I don't think even like one of the Mach 7 will pull this off.
Yeah. And then let's just think super speculative for a minute. So we have all these agents, they're attached to wallets, they're interacting with each other. You have like this full-scale, vibrant economy happening. Like what do you guys kind of envision here as like what that ultimately looks like, or maybe like the end vision for some of these like use cases and whatnot?
Yeah, I think like this is the question, which is like, what can the infrastructure we're building, what types of use cases can it enable that are not possible on centralized? And I think it is in the cooperation aspect. Like Web3 has always been best at the multiplayer cooperation type stuff. So how can we get these agents to cooperate with each other that can do things that just can't be done on Web2 platforms? I think that's the really interesting one. Some of the use cases that I've kind of thought about for these are things like the Stanford, Google generative agents use cases, like how big a simulation could we run with everyone's agents? And just by having all of those agents interacting, what sort of interesting things would they bring up, right? Like a simulation with millions of agents, we just have no idea. Other things are, people have done these multi-agent debate things where you have a bunch of different agents, they're given a task to solve, but they like debate the problem first. And then based on the debate that these agents have, the conversation and the outcomes of that, they use those to figure out how to solve the task. So you could actually have an agent on everyone's laptop, which is driven by data from that human. And you could just have these agents debating with other agents and trying to like find interesting conversation topics or outcomes or that sort of thing. These are some of the really interesting ones. I think what we're missing here, right, is like a language of cooperation. That's something that doesn't really exist yet. And I think it's related to like workflows, right? Like when I'm collaborating with another human, there's some sort of workflow that I collaborate with them in. So step one, do some sort of collaboration. Step two, we do some other thing in our collaboration, right? If we can create a language for these collaborations so that we can just write these kind of general workflows, we can have everyone's agents kind of interacting with each other in unique ways according to these workflows that we've built, right? And so I think what we ultimately need is to build like a hub of these different types of collaborations that our agents can engage in. And anyone can generate a new collaboration workflow which runs on top of all of these agents. And that's basically what NapthaAI is working on. And also OLIS, some of the multi-agent collaboration stuff, which can happen through the blockchain, for example. I think that's really going to open up some really interesting use cases.
Yeah, and I mean, let's go very far in the future at first and work back. I think, so it's obviously widely debated that, at some point we will have some form of AGI and then this will not stay static there and will progress. And I mean, it becomes quite fuzzy and impossible to say what will happen in some of those scenarios, right? And so a lot of the debate is about like us all ending up in some sort of situation where we'll be, overtaken by these agentic AIs and they'll enslave us or kill us or whatever because it's just easier that way. But I think if you then work a bit back, that's one potential outcome. There's other outcomes there. If you work a bit back, before all that happens, you have like huge economic disruption. Because one thing is very clear is as these systems get better, they replace more and more and more things which humans can do. And so people who have a lot of resources will probably initially be fine because they will also be able to own these systems. But there will be enormous economic challenges from this. So it's very important that we work out how we can not just create sort of aligned AIs, but also how we can spread their ownership out as far as possible, right? Like it's not good enough to have an open AI have like this super cool thing, it's super aligned to Sam, right? Like that doesn't really help most of the people in the room and probably all of us. And then working back from there, so we want to have basically agents which we can sort of co-own. Agentic AIs which we can co-own. So I'm kind of making the point forward because like when we're talking about agent or autonomous agent in particular, I mean, your AGI is going to be an autonomous agent. It's just like way more capable than what we're talking about here right now earlier in terms of use cases. Okay, so now we have defined what we've got to do is we have to basically co-own these systems. And that's ultimately like our mission at Autonolas is like building a stack so that people can co-own AIs, and then coming to the economy part, creating economies of these AIs where humans participate, software agents participate, and their interactions. And I think that's where a lot of exciting experimentation lies, because this is one of the points which we didn't cover in the previous question. Another big leg up Web3 has, or crypto over the centralized counterpart, is we have a way to create incentive mechanisms to get certain outcomes done, right? Like, it's mechanism design in economics. You look at things like BitTensor, for instance, they're kind of incentivizing people to create certain outcomes around models, and in a way, like, Olas is starting to create certain outcomes around agent economies, and I think there will be lots of other protocols, and this is what ultimately crypto is 100x, 1000x relative to your centralized whatever technology, which will just not enable that at all, right? So creating basically substrates which allow you to coordinate entire software agent economies is where it's at, in my opinion.
Awesome. And last question, since we're about out of time here, but you mentioned a collaboration language as being one of the hurdles to get over still. I'm curious, what other problems do you still see at either the technical or adoption level for these wide-scale agent economies?
Yeah, interesting question. I think we have a lot of the building blocks that we need to run agents. I think the thing that hasn't started happening as much as it could is a lot of these different projects working together. We're working with Olas now, putting together some different pieces of the puzzle, and also with Nevermind, for example. They focus totally on payments. Putting Nevermind together with Olas stack, maybe together with NapthaAI stack in future, I think is going to open up more use cases. But what we ultimately need is a way to put even more layers in the stack together. How can we include some proof of concepts of ZK and that sort of thing? I think ultimately we all need to come together in the space under some sort of vision, which isn't quite clear yet. Everyone is kind of just saying AI crypto over and over again because it's an interesting intersection and stuff. But I think it's about more than just AI crypto or the technologies themselves. I think we need to come together under a larger vision of this new type of platform that we're building that uses AI and uses crypto, but is also enabling a bunch of new use cases that weren't possible before. And I think we're still in the very early days of all of these projects coming together and putting these pieces together to enable that. So I think inter-project cooperation is probably the next step that we need to overcome to move forward, I would say.
Yeah, I mean, great points. And I think just to add to this before I put my own points, one of the things with autonomous AI agent economies in particular is it's so the opposite of zero sum, right? So no one has to worry that if they employ their effort, that somehow the other person will lose. I think totally not imagining, most people, how big this will be. We're talking about replacing entire sections of the economy and creating entire new economies. So let's just all work very hard and basically everyone wins. That's on that competition cooperation part. But what are the constraints? I think actually the biggest constraint is on the developer side right now, because if you look at crypto, it's already complicated. If you look at AI, it's complicated. Now you put the two together, it's even more complicated. And actually the intersection of the people who are even have experience in those two fields is basically very small. And the intersection of people who maybe want to have experience in this isn't large enough yet. And I think part of this is because you have the bad reputation of crypto, and then there's sort of a lot of AI people don't even kind of open their mind to the potential here. And also it's not trivial to transition into AI. I mean, it's not you can obviously use large language models and AI tools, but sort of starting to build more sophisticated architectures is hard. And I mean, that we're only just starting. Right now, we're, as Richard said, we could pause the clock in terms of like progress in terms of models, progress in terms of architectures, and could just integrate things, and we probably would go for 100 years and build amazing things. But then there's also this whole thing of pushing the models and the architectures forward, and there I think there's a lot of like building out of talent capacity still needed. So I would say that's one big thing, and then I think everything else will fall in place.
Awesome. Well, thank you so much. Give a hand to our panelists.